All right, welcome to the Explainer. Today we're going to talk about something you use every single day, but probably never think about. It's one of the unsung heroes of the internet. It's called UDP.
Okay, let me ask you something. You've been there, right? You're on a video call, and suddenly your friend's face turns into a blocky mess for a second. Or you're in the middle of an intense online game and lag. But when you download a big file like a movie or some software, it shows up perfect every single time. Why is that? Well, it's not a mistake. It's actually a design choice, a really clever one about how the internet ships different types of data around. So to get our heads around this, we have to look under the hood a little bit at something called the transport layer. The best way to picture it, think of it like the internet's own massive internal shipping department. Its entire job is to make sure a package, your data, from a specific program on your computer, let's say your Spotify app, gets to the right program on the other end, like Spotify servers. It's all about getting stuff from the right app to the right app. Okay, so here's where it gets interesting. Inside this shipping department, there are basically two main employees, two main ways to send your package. And they have completely opposite work ethics. One is the super careful, detail-oriented type who triple checks everything. The other one? They're all about speed. No frills, just get it out the door now. And these two employees have names, TCP and UDP. We can actually make this even simpler. Just think of TCP as sending a certified, registered letter with tracking. And UDP? That's like scribbling a note on a postcard and just dropping it in the mail. Yeah, this really breaks it down. Look at TCP, our registered letter. It's connection-oriented. What does that mean? It means before it sends anything, it actually calls ahead, metaphorically speaking, with something called a three-way handshake to make sure the receiver is ready. It guarantees every piece arrives and in the right order. It even slows down if it's sending too fast. Now, look at UDP, our postcard. It's connectionless. No phone call, no handshake, it just sends. It gives it its best effort, but there are zero guarantees. If a piece gets lost, oh well. It's pure, unadulterated speed. So for the rest of our time here, we're going to focus on that postcard, UDP, because it might sound kind of flaky, right? Best effort. But you'll see that its so-called unreliability is actually its secret weapon. It's what makes it so incredibly useful. Okay, let's look at the official definition. User Datagram Protocol. The keywords here are connectionless, we know what that means now, no handshake, and best effort. That's the whole philosophy in a nutshell. It's going to try, but its main priority is just getting the packets, which are called datagrams, by the way, out the door as fast as humanly possible. And this is how it pulls off that incredible speed. People call it the fire and forget approach. There's no wasting time with a formal hello. It chops the data up into those datagrams and just launches them. Each little packet is on its own adventure. If one gets lost in the digital wilderness or shows up late, does UDP care? Nope, it just drops it, gone. And that's the whole point. That lack of baggage of overhead is exactly what makes it so fast. Okay, so right now you're probably thinking, why in the world would I want that? A protocol that just loses my data? And that's a fair question. But it turns out for a massive chunk of what we do online, speed is king. Perfection can wait. Let's look at some real-world examples where this makes perfect sense. All right, first up, live video streaming. Imagine you're watching a live sports game. A single tiny data packet gets lost. Now, what would you prefer? Should the entire stream freeze for 2 seconds while we wait for that one missing piece to be sent again? Or do you just see a tiny pixelated block for a split second and the game continues? Obviously the second one, right? For live video, what's happening right now is way more important than a perfect picture of what happened a moment ago. And it's the exact same story for online gaming. This is critical. You're in a fast-paced shooter. You need to know where your opponent is this instant. Getting a packet with their current position is everything. Who cares about the packet that told you where they were 2 seconds ago? That's ancient history. If the game paused to wait for old data, it would be completely unplayable. It would be a disaster. Then there's voice calls, or VoIP, like Zoom or FaceTime. Think about it. Which is worse? A tiny crackle in the audio that lasts for a millisecond, or the whole call freezing in a super awkward silence for 5 seconds while the system hunts down a lost packet that was just the sound the. Yeah, I'll take the little glitch, thanks. It keeps the conversation flowing. And honestly, this quote just nails it. It's for those times when prompt delivery is more important than accurate delivery. That's the whole philosophy. For things like speech and video, getting it there on time isn't just a feature, it's the only thing that matters. So let's pull all this together.
UDP isn't a bad or unreliable protocol at all. It's not flawed. It's a precision tool designed for a very specific job. And it's a job that is absolutely crucial to how we experience the internet today, even if we never ever see it working. I mean, let's be clear. Without UDP, the real-time internet just wouldn't exist. Period. Forget about instant video streams, forget about responsive online gaming, forget about clear voice calls. All of that is built on the foundation that UDP provides. It really is the backbone of our live, interactive online world. And that's really the big takeaway here. It's all about that trade-off. UDP's flaw is actually its genius. It deliberately chooses speed over perfection. It sacrifices that 100% guarantee so that it can give us the raw, lightning-fast performance we need for all that instantaneous communication. So it kind of leaves you with a bigger question, doesn't it? In a world that's built on data, what's really more important? Total perfection or pure speed? UDP shows us there isn't one answer. It all depends on what you're trying to do. So the next time your stream glitches for just a half second, you'll know exactly why. It's not a bug, it's the price of admission for living in the moment. Thanks for joining me.